This slide is an important one in the sense that what we're really trying to show is that in a modern enterprise, the various use cases where PKI is being used is vast. Employees that are using VPN technologies, people who are using SSH authentication technologies in order to be able to remotely administrate cloud resources. Document signing as well, something that you might also be doing in your enterprise. Mobile devices, provisioning of networking gear, even IoT and DevOps, all of the different identity-based security systems that sit behind each of these use cases in your enterprise. As a CISO, as a CIO, if I'm a risk officer, I look at all of these use cases and realize I actually need to manage the certificates and make sure that the certificate issuance is correct, as well as all of the different things such as certificate expiry, the certificate profiling. Each one of these use cases needs to be unique. In the past, where you might have locked down the PKI behind perhaps your VPN system and even your mobile devices, as an example. Problem is, these new use cases such as DevOps and IoT and SMIME, which was always difficult, problem with those use cases is the PKI behind those systems, you might not have visibility. Governance becomes an incredible challenge. What we're trying to show here and what Lindsay will be talking about in his slide deck, specifically with respect to this slide and the ideas behind it, are how you create a single pane of glass for your identity-based security within your entire enterprise right across all of these use cases. So let's address these use cases very directly. And once again, what are the transformational use cases that we'll be talking about? Our mobile devices, DevOps, multi-cloud IoT, and of course, authenticated email. Email, of course, email's been around a very, very long time. But I think one of the reasons why we are revisiting it is because there are problems with it. The FBI, of course, has taught not that long ago the scale of attacks, business email compromise, and spear phishing are enormous, and the growth rate of attacks seems to be doubling on either a yearly basis or even more. But it's not just BEC, or business email compromise and fraud. It's also the stealing of intellectual property. Basically, what happens if in your enterprise you lost your emails? Well, to Sony, the result of that was millions or even more dollars worth of damage in terms of loss of intellectual property, as well as all kinds of embarrassment, which is now still out on the internet to this day. The Democratic National Party has had a large chunk of its emails be made public. Not something that I'm sure they intended or ever had wanted, but it had a large political impact.
Yeah, and if you want to talk about impacts on these things, Jason, you know, the Sony breach ultimately cost the CEO of Sony her job. As the CEO, you can lose your job because you're not pursuing this kind of security correctly. And the DNC breach arguably cost the Democratic Party the presidency. So, you know, the stakes are very, very high on these.
The problems with email, which is a protocol that we've been using now for decades and decades, right from the beginning of the internet, just seems to continue. One of the solutions that had been proposed years ago, which are SMIME keys, I'll just bring up one simple problem with this, which is when I talk to customers about SMIME, one of the issues they bring up is, well, if I lose my key, which is something that could happen just by a hard drive of a computer just dying, how do I retrieve my emails? I will essentially be denied my own emails. It's great that the bad guys don't have them, or aren't able to crack them, but I won't be able to see them either. Therefore, there's innovation needed to break this cycle of insecure email. All right, so let's talk about SMIME and what's required. Obviously, Lindsay's going to go into the roadmap of what SECTIGO is doing with this, but most of you out there who might know SECTIGO know that we are a big issuer of SMIME certificates, but we go beyond that. So let's dig further into SMIME. One of the things that we've added a lot of innovation to are a few areas that I'd like to highlight before Lindsay touches it much further. One of those things happens to be the secure email gateway. One of the problems with SMIME certificates that I know that I've talked to customers about is, how do I search my encrypted emails? And one of the things that, of course, with when you're just using SMIME certificates themselves, is an encrypted email can be quite difficult to search. But a secure email gateway takes advantage of the encryption key escrow service, which then allows a gateway to do a search mechanism on encrypted emails on your behalf. It's doing this in a very secure manner, and then gets rid of that main adoption point issue that plagues SMIME. Thankfully, we've innovated to solve that problem. Again, the encryption key escrow service, which is important for that secure email gateway, is also used to solve the problem where you might lose your SMIME certificate. If you need to re-provision a directory service or a mobile device or a laptop or a desktop computer where you happen to be using a copy of that SMIME certificate, those certificates are kept in a safe place, and whenever they're re-needed, either for the gateway service or re-provisioning, or even if you lose them, that secure place is now part of the automated SMIME management system that SECTIGO has. And one of the systems that I'd like to highlight always when I talk about innovation in PKI, innovation within SMIME specifically, has to do with new technologies in mobile devices. The operating systems behind Apple's iPhone as well as Android devices are now including MDM or mobile device management like technologies that we've actually embraced and taken advantage of to be able to have what we like to call a zero-touch provisioning. What used to be quite difficult in terms of provisioning users into your enterprise with SMIME certificates is now been made far more easy. That's something that, again, Lindsay will be touching on a little more in his roadmap. Let's go a little bit further in mobile devices and talk about how things have changed. I know that in the past, really wasn't that long ago, where much of what we did in an enterprise environment was dominated by a Microsoft stack of technologies. Let's take a look just at one particular set of technologies with mobile devices. Where does Microsoft stack of technologies sit within that? This slide suggests that it's less than 1/3%, but I would say that this is probably even less than that. And so therefore, PKI really needs to go beyond what was part of just the Microsoft tech stack of technologies, the Microsoft CA, which many of you are familiar with, and realize that you either have to go with an entirely new PKI that can actually deal with these operating systems beyond the Microsoft stack, or you need to augment your Microsoft stack in order to be able to deal with these other operating systems. And that's something else that, as SECTIGO, part of our design philosophy is to be able to deal with these new operating systems and new platforms that you'll be facing in your modern enterprise. So to push that analogy further, it's really all about trying to get those identities into all the different places where you need them. So whether you're wrapping your Microsoft CA proxy so that you can actually get certificates out into your networking equipment or your laptops, as you might have for a very long time, but also REST APIs in order to be able to have a very custom programmatic experience to provision certificates into applications or any other place where you happen to need them. One of the other things you'll see SECTIGO doing is embrace non-proprietary or open standards of provisioning technology. Many of you who in the mobile operating systems know about SCEP, but for other technologies such as IoT, we're now seeing provisioning standards such as Enrollment over Secure Transport or EST, but we also embrace proprietary EMM or MDM standards as well to provision your mobile devices. Certificates are going everywhere, and the ability to provision into each of these types of technology within your modern enterprise is very important. So therefore, part of the innovation has been not just the automation of certificate issuance, but the provisioning technologies that are important to get those certificates from the issuing platform to the destination that you need them. And I just want to pause and talk about DevOps as a transformational use case for a moment. The reason why we have DevOps, the reason why this new culture has been embraced by the modern enterprise is because of the fact that development teams and operation teams need to be able to work much more closely together in order to be able to put out product, in order to be able to build new systems. What used to be large monolithic ERP systems, as an example, are now being broken down into their constituent components, and that has required an entirely new set of technologies. And in fact, the entire set of technologies behind DevOps, I think where it's important with PKI, and to bring out the importance of this, especially for governance and risk officers who might not fully appreciate what's going on in the DevOps culture today, has to do with the fact that PKI is at the center of issuing identities to microservices, container systems, container orchestration systems. So each of these technologies actually has certificates as the basis of how these things operate across network boundaries. Obviously, we're talking about something that's introducing a lot of risk, whether it's breaches or non-compliance, things like outages that Tim was talking about earlier, these are even perhaps more important now with your modern web applications that are DevOps based. In terms of PKI, the risk factors that we're dealing with here are the sheer volume of certificates. What used to be somewhat difficult to manage manually in the days of just doing web server management for SSL as an example, think of each container being its own web server as an analogy. The volume of certificates in containers versus the number of web servers you have is more than 10 to 1, perhaps 100 to 1. The lifespan of those certificates is now getting shorter and shorter. Certificate lifespans can be as short as a minute, a few seconds, perhaps even less than a second. But keep in mind that your certificate orchestration engines are typically something that are within the hands of your operations and development staff. And therefore, the CAs or the certificate authorities that they're going to be running might be running in areas that are not in the same places where you're running your main human authentication PKI systems. And therefore, it's a decentralization of control. Are the certificates being issued into those certificates have a reasonable certificate policy? You don't know these things unless you can regain control. And let's not forget the fact that DevOps systems to this day are very, very complex. And therefore, that decentralization of control is amplified by the fact that you're now dealing with dozens and dozens of semi-related technologies that actually deliver your new modern enterprise DevOps applications. So how do we deal with that? Well, once again, on the left-hand side, SECTIGO's really, our core strength has always been about certificate issuance. But we've now pushed it farther than that. We've pushed it, of course, into automating the day in the life of a DevOps operator. That person, because they're probably building or maintaining a web application, is probably dealing with web servers and load balancers in their daily life, and therefore needing to have visibility to SSL certificate management. That same operator might also be needing to remotely administrate cloud resources with SSH. And then on top of that, the actual secure containers that are being issued by those people, they need code signing. And so therefore, the integrity of the code that's actually being implemented into your orchestration engines, just like you always needed code signing for code that you might issue in traditional enterprises. It's the same thing with DevOps, except that these containers are ephemeral, needing to be swapped out quite often, sometimes. And then in each of those cases, the integrity of that code needs to be protected, especially because of the fact that these systems might be in public clouds or in hybrid clouds, perhaps in areas that are not completely under control of your enterprise. It really highlights the importance of locking down those containers. And each of these containers in themselves needing to be provisioned with TLS certificates. If you're a DevOps operator, you might also be dealing with the issue of today you might be provisioned all of your loads on Azure, as an example of a public cloud. But tomorrow, your CISO or somebody else, perhaps your CIO, might say, you know what, I got a better rate with Amazon AWS. Why don't we swap over our loads to that service? Well, part of the problem with that is if you as a DevOps operator have actually hard-coded your services within the key management services of those public clouds, you might actually be locked in. Keep in mind that there are PKI trust models that can extend beyond just singular public clouds or any other type of cloud. Therefore, SECTIGO as a public CA can do certificate issuance in a trust model that extends trust across public clouds, private clouds, hybrid clouds, or perhaps even your partner's cloud. This is an important concept within PKI, the ability to have a hierarchy of trust that can extend across each of the systems will enable you to not just avoid getting locked in by a particular public cloud vendor, but also extend to you a more versatile modern enterprise, being able to extend trust across your different types of compute platforms as well as to third parties. And we're going to end with the idea of IoT, where PKI has had to evolve in order to be able to address the problem of IoT security. How did we end up in the situation we are with IoT security? The computer that you probably logged into today, probably you might have used a username and password, essentially a static credential. We know, of course, that static credentials or username and passwords have been problematic. What was one of the ways that we tried to solve that in a modern enterprise? Multi-factor authentication was an example. Problem with an IoT device is if you've hard-coded a username and password, you can't hand that IoT device a multi-factor authentication device and then be told, hey, just click the confirm button or get a one-time password in order to be able to authenticate yourself. An IoT device is not going to be able to utilize this. In the recent past, we've also seen that the management of digital identities within IoT has been very, very difficult. Using traditional technologies such as Active Directory or various other types of LDAP technologies has failed because of the scale needs of IoT. IoT devices, of course, are dealing with a scale that Active Directory and LDAP were never meant to deal with. And all of this really came to a fine point not that long ago when we saw a use case example such as closed-circuit televisions being provisioned with hard-coded username and passwords that were unable to be changed, which were then the basis of the Mirai botnet. The Mirai botnet code takes advantage of those static credentials within IoT devices and can mass harvest them for malicious purposes. It's almost certain that the people who manufactured those closed-circuit televisions probably never thought of themselves as a target for botnet purposes, which might be used for things such as denial of service against web resources. People who make those closed-circuit televisions might never have considered themselves as potential victims of that or their clients as victims of that. But the fact of the matter is, we've now been taught this by the people who were actually the originators of the Mirai botnet, of which there are variants still spreading to this day. The scary part about all of this is that all the various kinds of operational technology use cases that we've talked about a little earlier in this deck all have a problem of still using static credentials. Thankfully, what has changed in each of these use cases that you see in image 4 here is that the consortium behind each of them have chosen PKI as a way out of this problem. And I think one of the things I really do need to address is legislation that has now arrived. So as of January 1st, 2020, California law has been in place, which has basically addressed the Mirai botnet very directly and has basically, in a nutshell, said that devices need to comply with this concept of getting rid of static credentials, especially credentials which could never have been changed. There needs to be a mechanism to at least change those static credentials from one value to another within its life cycle. And even though that's not a complete solution for PKI, it's now forcing vendors to actually address this problem. Unfortunately, the speed at which vendors were trying to address this problem was slow enough that government did have to intervene. Now, moving further is a proposed federal legislation, which is now actually addressing the problem even further, saying that identity management, or essentially what is PKI, needs to be implemented in IoT devices. And so therefore, if you want to be compliant with future laws, especially even at the federal level, addressing these problems with modern identity solutions such as PKI is one way to keep yourself compliant. And one of the guidance documents that the federal legislation is actually pointing to directly is the NIST guidance from July of 2019, which says that not only do you have to protect the data security, but also the device security as well. These are the highest level risk mitigation goals that the NIST guidance actually is proposing. So how do you actually do that? Well, you also need to protect the firmware of the device, you need to protect the data in transit, and you need to protect the data at rest. None of what is in the California legislation addresses this directly, but the US federal legislation does. And so therefore, the future legislation goes much, much further. Problem with the California legislation is the fact that it does not address things such as data in transit, as an example. The problem is, even if you do have a mechanism that can change a static credential from one value to another, and therefore make you compliant with California law, the problem is that that credential might be sent in the clear and not protected as part of data in transit. Therefore, the bad guy who is actually watching the wire potentially can then steal that credential, and then we're back into the Mirai botnet scenario once again. Therefore, that is why that high-level risk mitigation that is actually been proposed by NIST as part of their guidance talks about this integrity of the device itself. So once again, you know SECTIGO as an issuer of digital identities. Part of what we also enable is the provisioning of IoT devices, which can be quite complex. We do this in several ways, not the least of which is programmatically through REST APIs, but also by embracing open standards such as Enrollment over Secure Transport Protocol, or EST. And further to that, we also offer technologies that help you to be compliant to NIST guidance. technologies such as TPM integration, which is the ability to take that provision certificate and put it into a hardened, secure element to protect that private key material, protection of secure boot, and also technologies to be able to monitor specific industrial or operational technology protocols. We offer those technologies ultimately so that within the operational lifespan of the device, all the data going back and forth between these IoT devices and their gateways or the cloud or other devices can actually be protected. Certificate renewal, which is something that in early IoT devices was difficult or impossible, those are technologies that we're now bringing to bear. So with this slide, I really try to offer that SECTIGO is a trusted third-party CA, an expert at PKI issuance at high scale, high agility, and usability. It is also bringing supplementary technologies to be able to have a full stack of IoT security. So where does SECTIGO play in public realm? And one of the areas that I deal with on almost a daily basis is dealing with standards of technology with respect to identity-based security within all these different consortium. So SECTIGO is actually the sole root of PKI behind the SunSpec Alliance, as well as co-root in the Open Connectivity Foundation, and also the WiMAX Forum Aeromax consortia as well. So those are ways in which SECTIGO has innovated and has participated in modern PKI.